Hello, hey guys. Now we are looking at lecture 11 for resistive transducer. So basically, resistive transducer is resistance of transducer varies the quantity. Okay, basically this topic talks about sensor that sensor detects the value of the input, and they are producing output in terms of changes in resistance, in R or impedance, right? So if they measure anything, they can measure speed, they can measure velocity, they can measure temperature, they can measure humidity, they can measure pressure, but the output they give out from the sensor is basically changes of R. Okay. So in this chapter, in this lecture, we are looking at three types of resistive transducer, which are thermistor and thermistor, Rtd, as well as potentiometer. Okay, so we look at thermistor. Okay, you can see it. Look at it from the photo. Okay, it takes that kind of package. It's a semiconductor device, basically resistance change value. Okay, when the temperature change. Okay, please take note on this statement. The increase in temperature basically causes decrease in resistance. So when the temperature goes up, basically the R goes down. So you have to take note of this for the thermistor. Temperature up, resistance down. Okay. So this is a relationship between the R and the E. Okay. Temperature change, R change. Okay. You have to basically, of course, understand this formula as well as memorize this thing, because the examination normally this kind of formula is not being given, so you have to recall and use it. So you have from the formula you have RT, the resistance that you are measuring, then you have T, the temperature, and R, because you are talking about all kind of temperature with all R. Are talking about new temperature, T, and what is the R basically. So RT is the temperature that you are measuring at temperature T, T1. Okay, and you have the previous R. You are measuring RT at temperature T. Okay, given the condition of RT1 based on the temperature T1. So basically you are putting a reference of all values to calculate a new one. Okay. So beta here is coefficient of the thermistor. Okay. So this is the graph. The temperature increase, the resistance decrease. Okay. These are the characteristics, the range, response time, and of course for this kind of R, for any kind of sensor that change resistance, okay, you need to use the bridge as a signal conditioner. Okay. That means as a sensor, you need to have signal conditioner within the bridge. Okay. This is another package of thermistor. So the advantage is basically low cost, small size, very high output voltage, and very fast response, because the package is small, basically absorb changes in temperature is quite fast. So the bad thing about the sensor is highly non-linear, meaning that you have issues when it comes to sensors which are non-linear. You have reading issues, you have many other issues, but you have to you can make correction by using a proper signal conditioner to improve the linearity of the reading. Okay. Next one is RTD. Basically, they are doing the same thing, measuring temperature and giving out resistance. The formula is there, R equal to R naught bracket T1 plus alpha delta T. Okay, you can see what is the R naught, alpha, and T. Okay, please take note that the statement there, as the temperature increase, the resistance increase. So it goes the other way around compared to the thermistor. For the thermistor, the temperature increase, the resistance go down, decrease. But for the case of RTD, when the temperature increase, the resistance go up, increase. All right. So you have the formula that you have to memorize. Basically, please take note for the delta T is basically the difference between the temperature at the time that you are measuring and the ambient temperature. Okay, this one is having some kind of reference to the ambient temperature. Okay, so this is the graph. Basically, it goes some of them are straight and some of them are not very straight, but you can say most likely it's a linear kind of sensor. Okay, of the graph also you can see as the temperature increase, the resistance increase, but it depends on the kind of material that you are using. If you are using platinum, you have this kind of response. If you are using nickel, you have different kind of response, but it goes the same direction. All right, the most common Rtd material, you have the platinum, nickel, copper, mercury, and tungsten. Right. So compared to the thermistor, you have extended temperature range. For the thermistor, you can go maximum up to 110 or 120, but for this kind of sensor, for the RTD, you can go up to 650, and for the nickel you can go to 300. So it's much more higher temperature compared to thermistor. Okay, that's the design more or less. It is much more stable, linear, much more accurate compared to thermistor, and of course it is expensive compared to thermistor. Okay, and the same thing here, you need a bridge circuit to get the value. So you need to connect this sensor to a Bridgestone circuit. That's this one. Okay, so you have to connect the RTD or the thermistor in one of the leg, R3 or R4. Then the output, you have to connect to a differential amplifier, and you already know this, right? Okay, and then because this is called that because for this kind of sensor you need power supply to work with, so some of the current or power will be sunken by the device, will be affecting the self-heating. So whenever you make measurement, you have to compensate the loss in terms of heat, because you are measuring temperature. If the sensor itself is being heated, so the measurement will not be accurate. So you have to recalculate the thing and compensate with the heat that generated by the sensor itself. So you have more or less follow this formula. You can see through the example to see what I'm talking about. Whatever measurement that you're getting, you have to compensate. You have to minus down the effect of the heating, okay, so that you can get the right and accurate reading. You can go through the example. You have solution there. So the last one we are looking at, a resistive transducer, is the potentiometer. So potentiometer is some kind of displacement sensor, works based on the principle of voltage divider. Okay, so okay, I have here with me the same material, more or less. So you have 1, 2, which is the fixed. So I have the wiper slider, which basically change the resistance. So I have 1, 2, and 3 terminal. So it works the same. Yeah, from the circuit you have 1, 2, and 3 terminal, and the middle terminal is the slider. Okay, so it works very simple using the concept of voltage divider. So you can calculate the output easily by using the formula. So this is just the package of how the sensor is being constructed. Okay, some go straight and some go, in circular base. This thing using, this is some kind of resistive sensor or potentiometer. Of course, this is the thing. All right, you can go through the example, see how the formula goes. But I can assure this is a very simple thing, just using 451 microsec. Another different packages of potentiometer. Okay, you can find this thing differently on different circuit. Right, I'm not gonna go into detail. And that's basically the end of lecture 11.